I'm just going to do some stuff. That don't make any sense, does it? There's a whole lot of state floating around in my head, and if I go to bed now, I'll forget in the morning what I'm doing. It's always nice to know that your Python generates valid C code. I don't know if that's doing anything. Hey there, welcome back. So in this video, we're going to expand on the code that I wrote before. If you remember, there's a link up there to the previous video. I'm trying to make a retro style game engine. It's supposed to deliberately be quite limited in what it can do. So it's going to have a 640 by 480 screen, 8-bit palette based display. I'm writing it in complete plain C, no C++ or anything. And it's mostly so I can try out game ideas separately to writing code for a specific system. Like, I'm trying to learn how to write code for a Spectrum next, and I keep getting tangled up between trying to write a game and also just learning how to get a sprite on the screen. So I need to split the two things up. Hopefully, I'll be able to reuse some of this code because it's C on maybe the Spectrum or on another system as well. So another thing I'm trying to do is make it data driven. Rather than typing out code to define things, I'm either going to write little utilities that generate code for me, like we'll do some of that today, working with these sprites, but also I want to be able to maybe load things off disk from files. So in today's video, there's a couple of things I want to achieve. I want to make these sprites animate. At the moment, they all look the same, and they don't move or animate. They can slide around the screen, but there's no sort of animation going on with them. The way I'm going to do that is if we just look at the sprites. So here's the Sprite Editor that I'm using, and each sprite is its own little cell, and you can see there's a standing sprite, 3 walking sprites, one that I guess is jumping, and one for if you get hurt. This is not any particular game at the moment. I'm just trying to get some basic mechanics working for moving sprites around the screen and animating them. So in this editor I can tag them. So I can say that this individual frame is a standing sprite, I guess. These ones here are part of something that I'm calling walking. Then this one is called jump and this one is called hurt. Now when I export this data from the Sprite Editor, one of the things it generates is a PNG file of all the frames. So there they are, one after the other, in exactly the same order that they came out the editor. Another file that it creates is this Json file, and it's split into different parts. There's a part for each frame which says its width and height and where in that graphic it is. There's some other stuff that I don't really care about. Then it has this bit that it calls metadata, and amongst it is these frame tags, and these match up with these here. Okay, so you can see that walking is frame 2 to frame 4, and here walking is frame 1 to frame 3. It would be nice if they'd numbered these the same, but that's 0 instead of 1, so it all makes sense. So I think we need to make a little list of things to do. So the first thing we need to do is to load this JSON file. Then we need to parse it and pick out certain bits. Right, for each frame, we need to know its X and Y width and height. Maybe the duration, because animations can have different speeds. Then we need to go into the metadata and pick out these frame tags. And we need to know the name from the two. This direction thing is how the animation runs. So a forward animation would just run 2, 3, 4, and it will keep going 2, 3, 4, 2, 3, 4. Backwards would run 4, 3, 2. And then there's one called ping pong where it would go 2, 3, 4, 4, 3, 2, like that. Which if I can play this, that's what it's doing at the moment. You can see it zipping backwards and forwards. And that makes a sort of more smooth walking animation. That's how these sprites have been drawn. So I need to deal with this, because it might be that for particular animations it needs ping pong, for others it just needs forwards. We don't care about any of this other stuff. I don't need to know the image file, because I'm going to load that by hand. So frame tags, which is the name from, to, and the direction. This is not what my engine is actually going to do. You're not going to feed this JSON file into the engine and have it parse it. The main reason being, parsing JSON data is a real pain in the arse. It's often nested, like this is a top level object called frames, but then there's another top level object here called meta, and frames is an array, and then each item in the array is an object that contains this key and value, but then contains another nested object with this data inside it. And drilling down through all this using C is really, really painful. I did find a JSON parser, but it was just so awkward to use I gave up. Instead, what we're going to do is my favorite thing, which is to write a Python program that emits some C code that I can just include. I've already done this for the palette that is used. So I've used JSON parsing in Python before. It's quite easy to do. You can just print the text to the screen and then capture it and redirect it to a file and include that. And then I can just have a header file that's got the sprite definition data inside it. So let's get on with doing that. I'm going to start with a copy of this file and then edit it. Right, so here's the beginning. This is just going to open a JSON file and load it. I can never quite remember how this works, so what I tend to do is just print out the raw data it's read in, and I kind of work backwards from that. Right, so down here you can see what it's printed out. So it's printed out frames and then this thing and then all this stuff. So let's just go like that. Okay, this is making sense. So do that. Okay, so that's got each thing. We want this frame object that's inside the frame object. Right, let's just make it print this out in human readable form so that I can understand what I'm looking at. Right, now we need to look through that, what is it, meta section. Let's get the JSON. So we just pulled these bits out for each frame. That'll do. Right, frame tags. That's in the meta section in a thing called frame tags. That's my Twitter. Click on my Twitter. So you can see how using Python makes this much easier. I can open these up as if they're just arrays with names. There's no fussing about trying to find which one it is. So we need each one of these. Right, so at the moment what I've managed to do is pick out from this JSON file the data I need. It's not in any particular format I can make any use of, and I can't put this in my code, but I've managed to pull it out of this file. This, where it's just me clicking on the screen and defining something in this editor into specific bits of data. So the next step is to work out how we're going to make use of this. So I'm going to have a structure that stores the first frame, the last frame, and the direction flag. So pretty much this stuff. And then there's going to be an array of these for each sprite. So this structure here, where I'm showing its dimensions, its hitbox, and its image, there's going to be another reference here to an array of sprite animation structures. And in there, that's where we're going to define this stuff. And then I'll make an enum of the names, and I'll make an enum of the directions. The directions I can just hard code that. But the names I'll need to pick out from this, so maybe we should do that first. That seems quite an easy task. Right, so we need to print out some C code. So here's the first bit. We've created the enum for the names. This bit here that says dude, I'll replace that later with the name of the file or something, so that there's one for each sprite, because it might be an enemy sprite doesn't have a running and a jumping. It has an attack 1, an attack 2, and an exploding or whatever. This is kind of apt at the moment, I think. This is the animation definition for a single sprite, so we can name it after the sprite. Right, if I've got this correct, what this horrible bit of Python does is it first counts how many of these definitions there are, so that we can make a definition in C for an array of the correct size, which is this bit here. So we're making an array of these that is, in this case, 4 big, because there's 1, 2, 3, 4 of these. Then we're going through those things and we're filling in the first frame, last frame, and its direct, which comes from here. First frame, last frame, direction. And we're using this funky Python print format to print out a literal bracket, then the from, the to, and the word animate underscore, which matches this bit, and then forward, reverse, and ping pong, which come from the direction in uppercase because it's an enum and that's the style. And then we print it. Now that should be valid C code. Let's just copy it. And paste it into somewhere just so we can try. I'm lost in my own source trying to figure out how to get here. Okay, I've just worked out an error. I couldn't include this file here, sprite definition.h. It just couldn't find it. So I tried thinking that maybe just my CMake files are all messed up. So instead of including it in here, I noticed that Sprite Manager was including, and look, where's the file? In the header section, look, there, Sprite Definition, Sprite Manager, next to each other. So I figured that should work, but it still doesn't. And then I noticed that actually, clearly I don't use this code anywhere important, somehow. Somehow the code still works, even though I'm not calling it properly, because I spelled Sprite wrong. Sprite. So let's put Sprite Definition in here. Oh, I see now why it compiled before. See, I was confused why this code was working even though the file was spelt wrong. I guess I must have tab completed it. Right, now we're getting on to errors to do with the C code that I've just created. And then it's happy with that, so that's valid C code. That's always nice to know. It's always nice to know that your Python generates valid C code. And if this looks a bit weird, the idea that I'm creating code using another programming language, I've done this before using Excel. I've created Excel spreadsheets that have had this kind of stuff in one column, and then the next column has got this stuff, and then the final column has got this in it. So this is a more repeatable way. But the idea is I can feed the JSON file from the Sprite Editor through this program and get a header file that goes in a folder. It's no different to the way I use CMake to generate a make file that then compiles all the code. It's just another step in automating everything. I want it so I can literally type make and it does it all. I don't have to manually click anything. So when I'm editing a sprite, I can do all this and I just click File, Export Sprite Sheet. I make sure that says Array. I hit Export. That bit's done. In here, it'll create this. and then there'll be a way in the make file to make it compile this through the Python program into C, and then it's in the program. This is what I mean about it being data driven. I'm not manually typing any of this stuff into a header file myself. It's a lot of effort to begin with, but once I've done it, and I never have to do it again. So we've got all that. We now need to get this. No, this bit. And we also need to stick it into here. So we need a sprite animation definition so that's an array of these things. I'll be able to remove some of this here. It can work out the width and the height itself. This hitbox thing really needs to be for every single sprite. See, this is all designed about a sprite being a single graphic, not a whole range of animations. Yeah, I can automate quite a lot of this, you don't have to type it in. So I've been redesigning this bit. A sprite definition now has the concept of there being multiple frames for each sprite. So we now have an array of frames, and that's going to be the width and the height and its XY position within the sprite atlas. Hitboxes we'll worry about when we do collision detection, but for now we'll have the concept that they can also be an array. Right, so these frame rects are these. One for each frame of animation. The index in this array is going to be that, because they're in this order. This array is ordered by this. Standing, walking, jump, hurt, which we're defining here. So in here we've defined the animation. We now need to define the frames. We need to know how many frames we've got. This here is classic programming, where you've got different quote styles to escape each other and some literal commas and some commas to separate things and different styles of brackets all jammed together. This bit here really confuses new programmers. When I teach Python, we look at this a bit and it's quite confusing for everyone. It's really hard to debug when you get things wrong too. So at this point we've defined the enum with all their names. These are going to be states later in a state machine. That'll be a future video. This is the frames of animation. This is defining what a standing animation is. It's from frame 0 to frame 0, so it's going to just play that bit over and over again. This defines a walking frame, which is frame 1, 2 and 3. So let's make this look a bit more like a header. I'd rather it picked out the actual name of the file, so I could reuse that instead of manually typing this in. Right, it now reads the file from the command line and uses the first part of the file name as the name of all the structure. So let's just look at our to-do. We've got all that stuff in. Nice one. Right, what we need to do now is create a sprite definition. And then pass it into the sprite engine. Right, so let's create the sprite definition. I don't need you anymore. Right, I've managed to fix my rather obvious mistake I was making here, because, you know, it's like 7 minutes past midnight and I really need to go to sleep. But I want to finish this, or I should go to sleep. But I really want to finish this because I kind of know what I'm doing now. There's a whole lot of state floating around in my head, and if I go to bed now, I'll forget in the morning what I'm doing. But I'm getting a bit tired, so I'm not really thinking what I'm doing. I'm just bodging code till it works. Right, you can't call a function here, obviously, because it's a function. I have a screensaver that's typing out, I think it's Apple II Basic, and on my screen I've got a mixture of Python writing C. Right, there's going to be a weird time jump because I'm stopping now, and then the next thing you'll see is tomorrow. Right, we're back. So as far as you're concerned, nothing's changed, but it's the next day. Right, I'm just going to get on with the next bit. I've had a think overnight and come up with a plan, and it'll just be easy if I do the plan and then explain it after. So here we go. I want one of these files per sprite, and then I want an overall file that kind of lists all these, because I've been thinking I can put this, I can generate that using my Python code. This definition can then just link an internal one of these with the one I pass in, and I don't have to do any of this stuff, which means I don't need to return an integer that I have to keep track of somewhere. Instead I can just have an enum of all the different sprites, which can then be passed into create instance. So I can pass an enum, so then I don't need to check if it's the right size or anything, and I don't need to keep track of it anywhere else. That should work. This Python file is going to get a bit more involved. So it needs to print this to a file instead of just dumping it to the console. I should point out that when I'm writing C, I like it to be correct and neat and tidy, and no weird tricks in code or anything. When I'm writing Python, anything goes. I just want to make the tool work. This is merely a tool. It's not an example of how to write good Python. This is a problem of going to bed partway through writing code. I had it in my head and I can't quite remember it anymore. It made complete sense. I've written some notes. The notes are a little bit cryptic now. I can kind of remember what I was trying to do, but it's a bit confusing. I always think it's important that generated code should look like code. You know, I could miss out all these spaces and indentations, and I could string it across one huge line. It's a generated file, the C compiler wouldn't care. But it's much easier for people if it looks like code. Okay, so after a bit of fiddling, I now have this Python generation code split into functions, and then a sort of master generate sprite header that takes a file name, does all the stuff, puts it in a file, and the result is one of these. Oh, that bit's wrong. Not to worry, we just take that bit, and then we write null. There we go. So now I need one of these for every single sprite. So I've written a little to-do list. you're going to feed it a folder, so this sprites folder, which will have multiples of these. And it's going to go through every single JSON file that it finds, make a header file, so calling this. Then we need to make an enum of all those files that we've loaded, and then some other bits and pieces. So the first step is to get a list of all the files in the folder. So files in, first argument ending in JSON. Right, that I'm thinking works. I only have one to test it with, but never mind. So I need to create an enum. So let's make another function. Cool. I've broken it. Look at all of this. Okay. Although it's doing 56 frames a second, dragging around what I think is a 640 by 480 image, so anyway, let's keep debugging. Right, after quite a bit of intense invasive surgery on the code, I've managed to get it right back to where we started. It looks no different. But let's just go through what I've done. We will start with the main program. So now in here, all you do is you call this init sprite manager function. This is generated from the Python based off this JSON file for the sprite, and it manages loading the sprites and checking that they've loaded, and then assigning each sprite definition to the list of sprite definitions. This is what I used to do manually, putting in the images and the data. Then it calls sprites init. Oops. Come on. And this is inside the main sprite code. So I've changed this to be like that because we've just defined it earlier. I now tell sprites init how many sprites we've just defined. And then when we draw them, this code has been drastically shortened because now I have a pointer to the current frame's rectangle. So that there that's popping around the screen. So now the point of all of what we've just done is that I can load up the Sprite Editor, define some sprites just using the Sprite Editor. It will then generate for me a PNG file of the sprite sheet, and it will also create a JSON file which defines every single frame, where in the sprite image it is, and these different states, and the frame it goes from and to, and how we animate it. And from that, it generates a bunch of C source code. So it creates a definition of each frame and definition of the animation. And then this is that sprite definition, the word definition's too many times in this, of an individual sprite. So it's frames, these get replaced later, and this. It generates a header for it, which has got the enum. They probably need better things because that doesn't apply in C. That in front of it, but we want it in uppercase. Now this is the nice bit. I just go into here, run one command, it regenerates the source. Right, there we go. So we've got dude standing, walking, jump. Everything is keyed off the name of the sprite, but that's a consistent thing within everything. Like, it's what the files are called, it's what the JSON has inside it. So the whole thing is named after the sprite. Now it looked quite invasive what I was doing to the code. There's a lot of chopping bits out and changing things, and this is just going to give you nightmares if you like looking at code that is nice to read. It's not terrible, it's just full of lots of little fiddly twiddly bits that are really hard to focus on. But as a user of this code, all I have to do is draw the sprite, define each frame, name the states for the sprites, generate the JSON file, run this Python, and then I get C source code already made that I just include. And all I have to do is make sure it compiles and call that. And that puts everything into the sprite manager and it's done. From then on, I just create instances using nice sensible names. And I can keep a reference to the sprite that was created and then use that later on. So all that horrible complexity has been hidden away. Don't have to worry about that anymore. So there we go. I guess the next thing to do is animation. At least the core way of making animation step through itself. I won't do a state machine just yet. So let's have a go at doing that. So what we need in here is to know which animation state we're trying to use, which will also be helpful later in the state machine that I'll build. Right, this will be greatly improved later. For now, this is just the basic bare minimum that's needed. Let's do something that will make it go berserk. Right, what this should do is very rapidly strobe through the different animation frames. Or at least the beginning one of each state. Don't know if that's doing anything. Hey! He's going berserk. There. So it's scrolling through every single frame. Right, there we go. It's working very, not the best, but it's proof of concept, it'll do. Right, let's work out what we need to do next time. Apart from buy a chair that doesn't creak and everything. Right, so next time we need a state machine. There we go, that's the next thing to do. We need some sort of state machine so that I can say the sprite is in walking and it will play the walking animation. And then if it's in jumping, it plays the jumping animation. Later that will turn into being able to give it some code to choose when it changes state. So if you press the arrow key to the left, it flips the sprite and puts it in walking animation. If you press the right arrow, it flips the sprite and puts in walking animation the other way. If you press space, it changes to jumping. Because then I can have a state machine where you can't go into like invalid states. Like if you're in the air, you can probably press left and right to move left and right in the air, but you can't press jump whilst you're in the air again. So yeah, that'll be next time. So what we've managed to do is take a load of complexity, force it into our program, and pretty much achieve what we started with. However, the point of this is to make everything data driven. So if I load up my sprites again, right, so the whole point of all this complexity is so that I can, when I'm trying to make a game, I don't have to think about chopping sprites into individual pieces and fussing around trying to animate them. It just works the same way no matter what sprite I'm working with. Right, so the idea is I could take this sprite sheet, which has got little frames of animation for a character doing whatever. I could load that into the Sprite Editor, split it up into different states, and define which groups of frames are that state. Then by just saving the sprite sheet and its JSON file, I can run it through this parser that I've created, and then it's done. I don't have to do any more thinking. I can just put that code in here, make sure it gets compiled, and then focus on writing like game logic. I don't need to manually copy and paste lots of sprite definitions. So there we go. Come back next time where we'll be looking at state machines and probably doing some equally invasive programming on this. And until next time, I'll see you later.